Today we're going to talk about genetic photosynthesis, or the possibility to capture more carbon dioxide during the artificial process. So, long story short, not to take away your time, we're going to talk about photosynthesis. What happens in a normal case of photosynthesis, we have a capture of CO2 plus H2O, which is water in this case, plus lambda. Lambda represents the visual spectrum of electromagnetism, and the chlorophyll, which is inside the place. What is very important for us, it is the oxygen that it is released into the atmosphere, and the carbon that is being captured from the atmosphere. Okay, that being said, according to some data, 200 billions of tons of oxygen are being released into the atmosphere, and 200 billions of tons of carbon dioxide are being also captured from to the atmosphere when we are talking about numbers. Now, slowly we're going to explain what is really happening inside, let's say, a leaf or a plant. How does the photosynthesis works? We have an upper and a lower protection layer, and in between we have mesophils, which is a polysubmesophil and a sponge mesophyll. In between there is a air chamber, and also there is a conduction tissue on the mesophyll. Now, they're really complicated chemical reactions behind this this process, for which I would not go into them right now, into those details, since are truly not necessary. However, I would like to explain the idea that we have and the, let's say, the talents that we are looking for at the moment, or let me say the scientists from one point of view, and the financial funds from another point of view. So, again, let me go back into the focus of the camera. What I'm holding here into the hand, let me make it more visible. It is a crystal. A crystal. Normally, there are a lot of companies producing crystals. The one that I know is Swarovski. Not that I want to favor it, just the only company that I know. Nevertheless, let's go back to the idea slowly and gently. Now, what are we trying to do here? We are trying to replicate the process of the photosynthesis in the artificial way. Now, inside the crystal, there will be a light phase and a dark phase. It is the same that we have in the normal, or let me say, the natural photosynthesis, where we would like to replicate the whole complicated mechanism that I previously explained. What is the purpose? The purpose is that we're going to get more oxygen. We will modify perhaps the lambda, which is the visual spectrum of electromagnetism, and in this case, we will work a bit into the dark. However, we will still going to use electromagnetism to trigger the whole process of photosynthesis. And in a heat-intensive processes where we have production, the gases are, I guess, approximately, depends on the process, around 1000 degrees Celsius. We will try to capture the carbon dioxide and replicate the photosynthesis within the crystal. However, very important process, it will be the cooling, okay? Because the photosynthesis is really sensitive onto hot and cold. So we will need to keep a constant somewhere here during the temperature. That being said, maybe it looks crazy, but it's just the way it is. I'm confident that we can find a solution together if we work jointly and if we join forces. So thank you so much for your time, and looking forward for your DM, direct messaging.